All right, today we are diving into a really fascinating condition called pernicious anemia. It's a case where the body secretly and kind of brilliantly turns against itself, and the consequences can be devastating. It all kicks off with a medical paradox.
So get this, here's the puzzle that starts the whole investigation. Imagine someone eating all the right things, plenty of meat, eggs, dairy, all packed with vitamin B12, and yet their body is literally starving for it. How is that even possible? It just doesn't add up, right? Well, this exact paradox is what sends doctors hunting for a hidden culprit.
And this is where it gets serious. The culprit isn't what you're eating, it's an inside job. We're talking about the body's own immune system launching a targeted attack. And if this attack isn't spotted in time, it can cause damage to your nervous system that you just can't undo.
So to really understand this internal sabotage, we first have to appreciate the victim in this whole story, vitamin B12. I mean, why is it so incredibly important for our bodies?
Vitamin B12 isn't just a minor player. It's absolutely fundamental. Think of it as a master key for your biology. It's essential for creating DNA, which you need to make basically any new cell. It's especially critical for producing all those red blood cells in your bone marrow. And on top of that, it maintains the protective coating, the myelin sheath, around your nerves. Without it, your nervous system is in big trouble.
Now, the body has this remarkably clever system for getting B12 from your food into your bloodstream. I love to think of it like a really strict, four-step passport control process. Let's walk through how this journey is supposed to go.
Okay, so step 1, stomach acid acts like a key, unlocking B12 from the food it's attached to. Step 2, it immediately gets a temporary bodyguard protein to shield it from that harsh acid. But here's the most important step, the main event. A special protein called intrinsic factor comes along and attaches to the B12. This intrinsic factor, it's the official passport. And without that passport, the border control in your intestine just will not let B12 in.
So you've got this perfect, elegant system. But in pernicious anemia, this is exactly where the sabotage happens. The immune system, for reasons we don't fully understand, decides to attack its own passport agency.
So what is pernicious anemia? Well, it's an autoimmune disorder where the body's own defenses get completely confused. They either go after and destroy the stomach cells that make the intrinsic factor passport, or they attack the passport itself, making it totally useless.
And the result of that is brutally simple. No passport means no entry, period. All that vitamin B12 in your diet, doesn't matter how much you eat, it gets turned away at the intestinal border. It just passes right on through your body. You're effectively starving in the midst of plenty.
So how in the world do we catch this internal saboteur? Well, the good news is, it leaves behind a very specific trail of evidence, and the first clues are hiding in plain sight, right inside a patient's blood.
And the key to cracking this whole case often lies in one of the most common, most routine medical tests there is, the complete blood count, or the CBC. This is our frontline detective tool. The single biggest red flag on that CBC report is a number called the MCV. It stands for mean corpuscular volume, which is just a fancy way of saying it measures the average size of your red blood cells. When that number starts creeping up over 100 femtoliters, alarm bells should be going off. This is a condition we call macrocytosis. So what does this actually look like? Well, on the left, you've got a normal, healthy red blood cell. It's round, it's uniform, it does its job perfectly. But on the right, that's a cell from a patient with pernicious anemia. See, without B12, the cells in the bone marrow can't divide properly. So they just keep growing bigger and bigger, becoming these large, fragile, and kind of misshapen oval cells.
But wait, there's more. We also see low hemoglobin levels, which is the anemia part of the name. And here's another classic clue, something called hypersegmented neutrophils. These are a type of white blood cell that has way too many lobes, more than 5, which is another dead giveaway that cell division isn't happening correctly. So the CBC really paints a clear picture of the chaos happening inside the bone marrow.
All right, so we've gathered the clues, we've identified the culprit. Now what? How do we solve the case? Well, this brings us to the diagnosis and, most importantly, the treatment plan for this lifelong condition. Let's look at a pretty typical case to see how it all comes together. Picture this. A 58-year-old woman comes in. She's tired all the time, she's got a weird tingling feeling in her feet, and her tongue is strangely smooth and red. Her doctor runs a CBC, and boom, her MCV is high at 112.
So they run more tests, which confirm her B12 levels are in the tank, and this is the smoking gun. She tests positive for antibodies against intrinsic factor. The diagnosis is crystal clear: pernicious anemia.
Now the treatment is just beautiful in its simplicity. We can't fix the broken passport system, so we just bypass it. We go around the problem entirely. Vitamin B12 is given as an injection, straight into the muscle, and from there right into the bloodstream. We start with frequent shots to build the body's stores back up, and then we move to a lifelong maintenance plan to keep those levels where they need to be.
And this is the part I really want you to take away. While the blood-related problems can get better pretty quickly with treatment, that nerve damage, that can be permanent if it's left for too long. And that's why catching those early clues on the CBC isn't just important, it's absolutely, potentially life-changing.
And that brings us to our final thought here. Dr. Yogesh really sums it up perfectly. He points out that pernicious anemia can be totally silent for years. But, and this is the hopeful part, with a careful reading of a simple CBC, it can be caught early and treated effectively. And that means we can prevent those lifelong complications and give someone their quality of life back. It's a medical mystery that's solved not with some single eureka moment, but by carefully, methodically connecting the dots.